The topic now we are going to discuss about is current electricity. In current electricity, most of the problems come related to circuits. Circuits in the sense it is only about resistors. Resistors, I think you all are familiar with the resistors. But the only problem in solving resistor problem is you may not know whether it is connected in series or parallel. How to identify this series or parallel? It's very simple. Series means end-to-end connection. Like now you can see in this, two resistors are connected in series, end-to-end, only one end is connected. And when we speak about parallel connection, now you can see that two resistors are connected in parallel in this case. How do I say that it is parallel? See, first two ends are connected. Similarly, the other two terminals are connected. It is called as parallel connection. So, first of all, you should be able to identify the difference between series and parallel connection. So, always you get a question like find out the effective resistance of the resistors. So, first you must be able to identify whether it is in series or parallel. The second thing, you must know the formula to solve it. So, when the resistors are connected in series, the formula to find out effective resistance or combined resistance or resultant resistance is R is equal to, let it be R1 and R2. So, that R1 plus R2. It's very simple. If the resistors are connected in series, just you can add it up. The next one is about parallel connection. If the resistors are connected in parallel, the formula to find effective resistance is 1 by R equal to 1 by R1 plus 1 by R2. If you know these two mantras, it will be very easy to solve the problems related to resistors. And even if you know all these resistors concept, it will be easy to understand capacitors problem too. So, shall we do some problems based on this? Okay. So, let us see the first problem. Now, look at this problem. Oh my God, it's too horrible. When you look at this, you think that definitely I cannot do it. But actually, it is very easy. I call it a successive reduction method. Successive reduction method means one by one easily we can try to solve it. Like this resistance is given, this diagram is given. Find out the effective resistance across A and B. This is your question. How we are going to solve it? Always keep in mind that we have to start from outer to inner. So, from when we consider this one, outer in the sense 3 ohm, 3 ohm. So, this is the outermost circuit, right? Now, look at this 3 ohm and 3 ohm. This end is only connected, right? So, which means it is in series connection. A, very good. So, series connection, what is the formula? R1 plus R2. So, it's very simple, 3 ohm plus 3 ohm. So, we get the answer as 6 ohm. So, very simple. So, now the answer for this part is 6 ohm. So, we are adding up these two resistors in series. Now, look at this 6 ohm. So, this is the resultant resistance of these two parts. Actually, I have solved only these two resistors. So, now this 6 ohm, the another part is there that you can see it as another 6 ohm. Okay. Now, this 6 ohm are in parallel. So, when it is in parallel, how do we find out the effective resistance? What formula did I tell you? 1 by R is equal to 1 by R1 plus 1 by R2. So, which means 1 by 6 plus 1 by 6, which is equal to 2 by 6. So, R is equal to 3 ohm. So, easily you can fix in your mind if the two resistors are of equal and then parallel, just we can take half of it. If the two resistors are equal and if it is connected in parallel, the resultant resistance will be of half of the value. So, 6 ohm and 6 ohm, what is our answer? 3 ohm. So, this you keep it in your mind. So, now this part also we have calculated. So, now finally what is our answer? 3 ohm. Now, this whole circuit effective resistance is 3 ohm. This 3 ohm and this 3 ohm are connected in series. Again, what will be the answer? Yes, you are right. 3 plus 3 equal to 6 ohm. This 6 ohm are connected in parallel. So what did I say for parallel? The answer will be half. So again you will be getting 3 ohm. So for all these resistors, the effective resistance is 3 ohm. Now 3 plus 3 equal to 6 ohm. Again 6 and this 3 are in parallel. But here both the resistors are of different value. Keep it in your mind. So here we got it as 6 and this is 3 ohm. So what will be the final answer? 1 by R is equal to 1 by 6 plus 1 by 3. So when you take LCM, 6, 1 plus 2. So this is equal to 3 by 6. So R is equal to 2 ohm is the solution of this problem. So let me explain it once again. A diagram is given. You are asked to find out the resistance between A and B. We have to start from the outermost circuit. So start from this. 3 and 3 are in series. 3 plus 3 equal to 6 ohm. Now the 6 and 6 are in parallel. Parallel equal half of the value. So 6 and 6 means the answer is 3. 3 and 3 are again in series. 3 plus 3 equal to 6. 6 and 6 are in parallel. So the answer is 3 ohm. 3 and 3 are in series. So 6 ohm. 6 and 3 ohm. So this we have to solve by using the formula 1 by R equal to 1 by R1 plus 1 by R2. So the solution is 2 ohm. Is it clear now? Shall we do the next problem now? Okay, in the next problem, again you see, it is given in different way, like it's like a square and some resistors are connected. Again definitely you will be tensed, but it's very simple. Again we have to start from the outermost circuit. So what is the outermost circuit here? 7 and 3. How are the 7 and 3 ohm connected? It is in series. So 7 plus 3 is equal to 10 ohm. Now this 10 ohm and 10 ohm are in parallel. 10, 10 parallel. So half of the value. So the answer is 5 ohm. So 5 ohm plus 5 ohm are in series. So 10 ohm. 10 and 10 are in parallel. So the answer will be 5 ohm. Let me solve this 7 plus 3, 10 ohm. So 10 ohm and 10 ohm are in parallel. 10 ohm and 10 ohm. So when we solve this, we get the answer as half of the value. So this will be equal to 5 ohm. Now this 5 ohm and 5 ohm are in series. So again we get the answer as 10 ohm. This 10 and 10 are in parallel. So the final answer will be 5 ohm. Okay. So let us do the last problem. Now look at this problem. So here it's given in the form of circle with few resistors. So how can we solve these kind of problems? You might have seen this question in your paper, neat paper. So all are equal resistance, but it looks very complicated. So how we are going to solve this? Okay, look at this diagram for 1 or 2 minutes so that you will get some idea of it. How it is connected? One end connected and similarly the other end is also connected. If both the ends are connected, I said it is parallel connection. So these two are in parallel. So similarly here also it is interconnected. So definitely we can say that all these three resistors are in parallel connection. Okay, now look at this. So these three are in parallel. To that parallel, the fourth resistor, that is the end A, is connected in series. So this is our resistor after doing reduction. So how we are going to solve this? Now these three resistors are connected in parallel. The formula for solving in parallel is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here it will be 1 by R plus 1 by R plus 1 by R. So what will be the solution? 3 by R. So R effective, this will be equal to what? R by 3. So this part we have solved and our answer is R by 3. Now this resistance and the next resistance are in series because only one end is connected. So it is in series. Again for series connection, what will be the formula? It should be added. So R by 3 plus R. This is equal to R plus 3R divided by 3, which is equal to 4R by 3. So that's it. So how we solved it? While looking at the diagram, it looks very complicated, but when you look at the diagram for 2 minutes, immediately we can identify that these three are interconnected. So definitely these three are in parallel, and the next resistor is connected in series. So accordingly we have drawn the diagram, and for these three resistors in parallel, the effective resistance is equal to R by 3, and now this R by 3 and R are in series. So when we add it, the solution is 4R by 3. So when you do these kind of, when you practice these kind of problems, definitely it will be easy to you.